Okay, good morning. Our last week of our circles unit. So unit 10, classwork 13, we're going to do equations of circles centered at the origin. And then we're going to move them off the origin on Wednesday. So prior knowledge, you're going to need this formula, the distance formula here. So find a place to make sure that you can reference that or write it down. But we're going to use the distance formula to find the distance between each pair of points. And notice how the distance formula that x1 minus, or x2 minus x1, remember our hypotenuse equals the square root of a squared plus b squared, where we're talking about the altitude squared plus the base squared. We did that whole unit in the murder mystery project on that. So now we're just looking at the individual coordinate points, and to find those distances, we just subtract our x's and we subtract our y's. So here we go. If we're going to use the distance formula to find the distance between these 2 points, then the distance is, and when I do this, I like to set up the structure. Oh, for Pete's sake, here we go. I like to set up the structure and then solve. So it's always going to be the structure. It's the Pythagorean theorem underneath. And if you want, you can always identify which ones are x's and which ones are y's. Somebody like me with some dyslexia has a hard time, things move around, so this might be a strategy for you. So here we go. 10 minus a minus 2. So 10 plus 2. And 12 minus 7. So that is d equals 10 plus 2, 12 squared, plus 12 minus 7, 5 squared. 12 squared plus 5 squared. You can plug that into our little calculator, or you should see, you've seen this right triangle several times, and the distance is 13. Same idea here. So we have 3 minus 1 and 4 minus 7. On the second one, it's going to be negative 3, but negative 3 times negative 3. Remember that negative 3 is inside the parentheses. So our distance is going to be the square root of 2 squared plus negative 3 squared. That distance is actually going to be the square root of 13. And you can leave it like that. Until you get to your final answer, you should carry that square root through if we're going to be using it in another calculation. Make sure you leave it under the radical and only round at the very end if possible. And here we go. Equals square root. We've got 15 minus 9. And we have negative 2 minus a minus 4, so plus 4 equals square root 15 minus 9. Well, that's 6 squared. 2 squared. So 36 plus 4. Distance equals the square root of 40. And 40 is 4 times 10, and the square root of 4 is 2. So distance equals 2 square root of 10, if we were to simplify that. All right, here we go. That's our prior knowledge. Make sure you know this equation. Equations of a circle centered at the origin. So here we go. What is the radius of circle K to the right? So I can find the radius, the whole diameter goes through the center and all the way across, it's the longest chord, but the radius is half that, and I can see the radius. In quadrant 1, quadrant 2, quadrant 3, quadrant 4. In quadrant 1, find the point on the circle where x equals 6. Well, let's see, here's x equals 6 right here. So when the line x equals 6, what does y equal? Well, in quadrant 1, when x equals, oops, hold on. I did x equals 5. When x equals 6, right here, let's do it in a different color. Right here. There we go. When x equals 6, y equals 8. And so the intersection on the circle is the point 6, 8 in quadrant 1. It says draw a right triangle off this point and the origin and use the Pythagorean theorem to find the hypotenuse. So I'm going to go back to the red. Look at this. So let's use the Pythagorean theorem. This is a height of 8. This is 6. And you should see that that's a scaled up version of the 3, 4, 5. But if not, our hypotenuse equals the square root of 6 squared plus 8 squared. 36 plus 64 equals the square root of 100. So our hypotenuse equals 10, but our radius also equals 10. And here we are. We started the year with Pythagorean theorem. And if you take that radius and spin it all the way around, you can make right triangle after right triangle after right triangle. Let x, y represent any point on a circle with the center of the circle at the origin with radius r. The equation for a circle centered at the origin has x coordinates, y coordinates, and your radius. So for circle 10, we've got x squared plus y squared equals, and our radius is 10, 10 squared, 10 squared, x squared plus y squared equals 100. Make sure you are always evaluating this. Simplify, evaluate. All right, so let's look. We can figure out the radius for each one of these. So if we have a circle, and the equation for the circle is x squared plus y squared equals 36, and we know r squared equals 36, we know r is 6. It can't be the negative 6 because you can't have negative length. R squared equals 121, r equals 11. And the last one, r squared equals 25, r equals 5. Well, what happens if it's not a perfect square? Well, what happened up here when it wasn't a perfect square? We can simplify to the best of our ability, or if it's a prime number, say like in part B, we can just move it into the radical. And then you might be asked to just put it in an approximate. So round to the nearest tenth, round to the nearest hundredth. So state the radius for each of the given equations, leave your answer in exact simplified form. Well, we know r squared equals 7 means r equals the square root of 7. And 7 is a prime number, so we can just leave it under the radical. 12 is a composite number. So let's look at 12. R squared equals 12. So taking the square root of both sides, 12 is not prime. 12 is r equals the square root 4 times 3. It's also 6 times 2, but 6 isn't a perfect square. You always want to simplify, pull out your perfect squares. And so the square root of 4 is 2. R equals 2 radical 3. Super important. This is what kids in Algebra 2 are doing right now and pre-calc. R equals the square root of 20. R equals 4 times 5. R equals 2 radical 5. For each of the following, we want to write an equation for the circle that is centered at the origin. So what do you notice on the first one? It's going to be x squared plus y squared equals, and then we do the radius squared. And the radius is 1, and 1 squared is 1. Here, our radius is 10. R equals 10. So x squared plus y squared, 10 squared is 100. Here, r is 4. 4 times 4 is, that's right, 16. X squared plus y squared equals 16. So that's how we would write the equation for a circle. The equation for a circle centered at the origin is x squared plus y squared equals r squared. It has 3 variables, x, y, and r. And you know on your graphing calculator, you can't put in what is y squared equal or what is x squared equal. It's always what does y equal, okay? And when I look up here, all these circles, if I did the vertical line test, it's not a function because for each x, notice there are 2 y's. And so to get around that on our calculator, we can do something special. If we know any 2 of the variables, we can find the third. So if we're given the radius and the x coordinate, we can find y by rearranging the equation. So subtract x from both sides, and know that when you do the square root, you're going to have a plus and a minus. Now, we're not talking the length, we're talking coordinate points. So notice how there are 2 answers. In order to draw or graph on your calculator, you can do y1 equals the positive square root, and y2 equals the negative square root. And that's how you're going to be able to draw positive and negative. That's how you're going to be able to draw a circle on your calculator. So notice this has 2 answers. Due to the plus minus, this is expected because there are 2 points on the circle that have the same x coordinate. On the right is shown that for a given x coordinate, we see 2 points, point 1 and point 2, that share the x coordinate. So find both values of y if we know x is 77 and our radius is 85. y1 equals positive square root. So what is our equation? R squared minus x squared. That makes sense. Hypotenuse squared minus a leg squared. So we'll go radius is 85 squared minus x1 77 squared. When you actually put this in your calculator, y1 is 36. y2 equals the negative 85 squared minus 77 squared. So y2 is going to be negative 36. So this is going to be the point 77, 36. This is going to be the point 77, negative 36.